There are many specifications that show how a DC motor is built, including the gauge of the wire used for each coil, the number of turns and/or conductors in the armature slots, the end connections of the coils that form each coil group, connections between coil groups that form the windings, the power supply line connections to the motor. Information on the gauge of the wire, number of turns and/or conductors in the armature slots, end connections of the coils that form each coil group, connections between coil groups that form the windings, and the power supply line connections to the motor is needed to wind and connect a motor properly. But one drawing would be too complicated to represent all of this information. In order to make there is the first diagram that represents the winding and connecting of the stator coils in groups. A second diagram shows how these groups are connected. The third diagram details the assembly of the motor, which includes connecting the windings to a rheostat, if used, and to the external power or line leads. This winding distribution chart represents a simple winding, using a single strand of wire throughout the motor. This winding distribution chart is for a more typical DC motor, and it includes the size of the wire, the type of insulation covering the wire, the number of strands per conductor, the total number of strands in each slot, and the connection of the coils in a group. After a stator or armature coil is wound, the next step is to connect the coil groups together. The group's connections are represented in the group connection diagram. To avoid confusion, these diagrams are usually drawn in the form of a circle. This is a section of a stator connection diagram. A diagram like this would also be used to show rotor or armature connection. A wiring diagram lists the internal connections from one winding to another winding and to any other devices in the motor. A line connection diagram shows the allowed connections of the motor leads to the line. If there are only two leads to the line coming from the winding, this type of diagram is generally not necessary. This diagram of a compound wound motor shows you many things about the wiring of the motor. Here is the shunt field winding, which is connected to the rheostat. Here is the compensating field winding, which is connected directly to the commutating field winding. This is the series field winding. There are different coils in a DC motor, and each is important to the motor's operation. Therefore, you must be familiar with all of them. Which of the following is not a specification that shows how a DC motor is built? A. In the diagram shown here, identify A and B. A. Shunt field and compensating field windings. B. Compensating and commutating field windings. C. Shunt field and commutating field windings. This diagram of a compound wound motor shows you many things about the wiring of the motor. In the diagram shown here, identify A. In the diagram shown here, identify A,